So this is a very common question we have from our customer. They always ask, why total station, why GNSS, or why geotechnical? So today we will try to explain what is the strength of each device in each situation, I will say. So 5 things to consider. First, I will say is the budget of your customer, of course, the distance you want to cover, like which area, what is the size of the area you want to monitor, which period, like is it for 1 year, 1 month, 1 day, atmospheric correction condition, and site condition. So our free monitoring type, I will say there is a total station. So which case we use total station. So we use usually when you have absolute movement. So with a total station, we monitor XYZ position, and then we calculate our baseline, and then we compare this position to your current position of your installation. So this monitoring is high precision, less than 1 millimeter accuracy. So it's pretty low cost because after you, I would say, invest on the instrument, the cost of Prism is pretty low. And you can monitor many points from the instrument. We have some customers, they monitor with one instrument, hundreds of points. The range you can have up to 2,500 meter with a long range instrument. And after, like I will say, the measurement, the frequency will depend on how many prism you have. More prism you have, longer it takes. So this is why some people add additional instruments in order to increase the frequency of measurements. Then the second point to consider, like GNSS, is like a total station, measure absolute movement, so XYZ position. And it will compare like the initial position of your building with the baseline. And after you will have your movement during the project. The good point with GNSS, it doesn't need line of sight, but you need like open environment. So for example, you cannot install a GNSS close to the wall because of the multipass problem. I think Roland explained last time in a second part of the webinar. And what is good with GNSS, you can have like a very high frequency measurement up to 20 Hertz. So you will have 20 measurements per second, which like can detect like a high frequency displacement. And then like the geotechnical, so the topic of today, geotechnical is usually used for local displacement. So it will measure like an angle displacement or just a local variation of the ground. So it will monitor a wide variety of data type, since you can use a lot of different sensor type. There is no data gap, and it does not require line of sight because all the communication is over radio. It's very easy to install because you just like sometimes glue or bracket, and also you can measure a point up to 15 kilometers from one gateway, and you can also install up to 100 sensors per gateway. And you can have high measurement frequency. So basically the lowest rate you can go is 1 minute. And also most of the sensor, as I mentioned before, ran on battery. So you have a pretty, usually you can monitor like for a long time. So as I mentioned before, it's very difficult to say one solution is better than the other one, because like one is for absolute measurement, total station and GNSS. So you really measure like a displacement of the position, when geotechnical is more like for relative displacement. So usually our customer, they really combine these two solutions in our software Trimble 4D, who makes the analysis, report, and graph of your displacement. So our software allow you to merge this data from total station, GNSS, and and geotechnical sensor in one platform to have a very comprehensive monitoring analysis.